Hello, I am Satyabroto. Welcome to my channel. If you want to get the updates of new videos, then please like, share and subscribe my channel, and don't forget to click the bell icon. So today I am going to discuss Sp2 hybridization, and for this I am considering ethylene, which is the simplest alkene. So to explain the tetravalency of carbon, we know we have to consider the excited state electronic configuration. So what is the excited state electronic configuration? If we consider only the valence shell, then excited state electronic configuration is 2s1, 2px1, 2py1, 2pz1. So here 2s orbital, 1 2s orbital, and out of 3, 2 2p orbital are mixed to form 3 sp2 hybridized orbital, and the 2pz is unhybridized one. Okay, so as we are arbitrary, and here we are arbitrarily chosen to hybridize the 2px and 2py. So you can choose 2px or 2pz, but here I have considered 2px and 2py among the 3 2p orbitals. So each orbital has one part that is 33% s character. So percentage of s character is 33%, and percentage of p character is 66%, and these orbitals are called sp2 orbitals, and the here carbon is said to be sp2 hybridized. And we know that the 2px and 2py orbitals are used for hybridization, and 2s orbital, which is spherical in shape, and 2px and 2py, their axes are x and y respectively. So the sp2 hybridized orbital will lie in xy plane. If you consider 2px and 2pz, then sp2 hybridized orbital will lie in the xz plane. Clear? So and the so I'm drawing the sp2 hybridized orbital, how it looks like. So if I consider my screen is xy plane, then sp2 orbital will lie in xy plane, three sp2 orbitals, each contains one electron, and the unhybridized p orbitals, the unhybridized 2pz orbital, its axis is the z axis, which is perpendicular to the plane containing the axis of the sp2 orbitals. So this is unhybridized 2pz orbital. Okay, so conceptually ethylene can be formed in the hybrid orbital model, but before going into ethylene, so I can say that this sp2 orbitals, the bond angle between two sp2 orbitals is 120 degree. The maximum separation is 120 degree, and the bond angle between 2pz and one of any sp2 orbital, that is 90 degree. This is 90 degree. As I am just I have just told you that conceptually ethylene can be formed in the hybrid orbital model, where two sp2 hybridized carbons atoms are involved, and 4 hydrogen atoms are also involved. So but we need to first I need to show you the three-dimensional view of ethylene molecule, then I will put the sp2 hybridized orbital, and then we will understand how hybrid orbitals looks like. See, this is the three-dimensional view of ethylene. So this is carbon, and these 4 are hydrogen. Okay, so I think you have understood. So CH CH CC double bond CH CH. So the bonding pattern, the hybridized orbital, I'll explain soon. First I will show you the sp2 hybridized orbital. So this is one of the sp2 hybridized orbital. These reds are sp2 hybridized orbital, and green circles are indicating the 1s of hydrogen. And the pink one is the 2pz or unhybridized orbital. So here this is 1s1 sigma bonding between 1s1 of hydrogen and sp2, one of the sp2 of carbon, this sigma bond. There is also one sigma bond, this is, and this is the sp2 sigma bond, sp2 of one carbon atom and sp2 of another carbon atom forms the sigma bond. And here also sp2 hybridized, sp2 orbital of carbon and 1s1 of hydrogen. Here is also same sp2 orbital of carbon and 1s1 of hydrogen. And so this is 2pz and this is another 2pz. So they will form the pi bonding, that is 2pz parallel sidewise overlap, pi bonding. Now I'll show you the only the pi skeleton, or how it looks like. I think you have understood. I can take this view. Okay, so here I am showing you the only the 2pz orbital. See, it is clear that 2pz orbitals, the pi bonding, are perpendicular to that of sp2 orbitals. See, this is 1,3-butadiene. All 4 carbons are sp2 hybridized, and I will show you the pi framework of 1,3-butadiene. Let's see. As I am to show you the pi framework, so here just I am drawing the 2pz orbital. These are the 2pz orbital. In each 2pz orbital are each 2pz orbital contains 1 electron. So this is pi bond and this is another pi bond. So remaining are sp2 hybridized orbital. So just I am not going to show you, then then the picture will look very messy. So I think you have understood the sp2 hybridized orbital. So thank you. If you like my videos, then please subscribe my channel and don't forget to click the bell icon. Bye.